Welcome to another deep dive. We've got some really cool factoids lined up for you guys today, all about photoluminescence. It sounds a little intimidating, but I think we'll be able to shed some light on it. Haha.
Definitely. Happy to be here.
Okay, so I've got these notes in front of me, and the first one is just like a basic definition of photoluminescence: light emitted by a substance after it absorbs light. I mean, that already sounds pretty amazing to me, but I'm guessing there's a lot more to it, right?
Yeah, for sure. It is a pretty captivating phenomenon. At a basic level, it all comes down to the substance absorbing light energy. And then that energy excites the electrons in the material. And so then those excited electrons jump to a higher energy level, and when they fall back down, they release that excess energy as light.
So it's kind of like, I don't know, like those little bouncy balls that you drop and they come right back up.
That's a good analogy. And you know what's even cooler? The light that gets emitted is often a different color than the light that was absorbed.
Oh yeah, that is pretty wild. So why is that? What makes the color change?
Well, think of it like this. When you throw a ball uphill, it loses some energy rolling back down, right?
Right.
Similarly, when those electrons fall back down to their ground state, they release less energy than they initially absorbed. That difference in energy translates to a longer wavelength of light, and that's what causes that shift in color.
Huh. Okay, so now we got these other two terms, fluorescence and phosphorescence. Both involve emitting light. So what makes them different?
You got it. It really just comes down to timing. Fluorescence is all about that instant reaction, kind of like that bouncing ball we were talking about. The substance absorbs light, gets excited, and boom, it emits light pretty much instantaneously.
So it's like that instant gratification thing, but with light.
Exactly. Now, on the flip side, you have phosphorescence. That's more like a slow burn. It's like the afterglow you see in those glow-in-the-dark toys.
Oh, okay. So it's more of a gradual release of energy then.
You got it. The excited state in phosphorescence lasts much longer, so the emitted light kind of lingers for a while, even after the initial light source is gone.
So fluorescence is like a quick burst, and phosphorescence is like the after party.
I like that. It's all about the time scale of how that energy gets released.
Gotcha. Now, I also see something here about LEDs. I remember when those were all the rage, super energy efficient light sources. So what's the connection between LEDs and this whole photoluminescence thing?
Well, a lot of LEDs, those are light-emitting diodes, by the way, actually use photoluminescent materials to make the light we see. Specifically, they use these special semiconductor materials that when you pass an electrical current through them, they emit light.
So it's the electricity that's giving those electrons the initial boost in LEDs.
Exactly, but to get the whole spectrum of colors we're used to seeing, like in those fancy mood lights you mentioned earlier, they often have to add in these photoluminescent materials. They're called phosphors in this context, and they basically help to fine-tune the color of that light that gets emitted.
So it's like a two-step process. The semiconductor gets things started thanks to electricity, and then the phosphor comes in to make those really vibrant colors.
Exactly. It's a pretty ingenious way to produce such a wide range of colors. If you think about it, LEDs are everywhere these days. Your phone screen, traffic lights, all kinds of things. They all rely on this combination of semiconductors and photoluminescence.
Wow, so this phenomenon is lighting up our world, literally. It's incredible how something so fundamental can play such a big role in so many technologies. Speaking of lighting things up, let's move on to this factoid about bioimaging. It mentions something about using fluorescent probes to visualize cells and tissues. That one definitely piqued my curiosity.
Oh yeah, that's a fascinating application. You can actually see the inner workings of cells and tissues light up right before your eyes. It's pretty remarkable.
It sounds kind of sci-fi, to be honest. So how do these fluorescent probes actually work?
Basically, these probes are specially designed molecules that can attach to very specific targets within a cell or tissue. And then when you shine a particular kind of light on them, bam, they fluoresce, making those targets visible under a microscope.
So it's like giving those cellular components a little glow up so scientists can track them, huh?
Yeah, exactly. This technique lets researchers visualize all kinds of cellular processes in real time. It's amazing, like the movement of proteins, how cells interact with each other, even the activity of genes.
That's incredible. It's like having a front row seat to the microscopic world inside of us.
It really revolutionized biological research. Imagine trying to understand what goes on in a cell without being able to see anything.
Oh man, it would be like trying to navigate a city in the dark. So just to recap, we've covered how photoluminescence works, the difference between that quick-acting fluorescence and the slow glow of phosphorescence. And we even touched on how LEDs use this whole phenomenon. So what other cool stuff is there to learn about?
It's really cool to see how photoluminescence is already like all around us in things like LEDs. But what's really exciting is how scientists are using it to like push the limits in other fields, like renewable energy, for example.
Oh yeah, I was reading something about that, like using photoluminescence to make solar cells more efficient.
Exactly. Researchers are working on these like cutting-edge solar cells that use these special photoluminescent materials to capture, a wider range of sunlight's energy.
So instead of just absorbing certain wavelengths of light, they can like upconvert those lower energy photons into ones that are more easily converted to electricity.
Exactly. It's all about making those solar panels as efficient as possible, which, could make them even more attractive as a clean energy source. Like, imagine a world where, all our homes and cities are powered by the sun, and it's thanks in part to this cool photoluminescence thing.
Okay, that is a future I can get behind. It's amazing to think that something like light emission, something so fundamental, could hold the key to like a more sustainable future. And speaking of like game-changing applications, I also have something in my notes here about personalized medicine. That sounds pretty futuristic, to be honest.
Yeah, it does, doesn't it? But it's closer than you think. Scientists are already developing these like tiny little photoluminescent sensors that can detect specific biomarkers in the body. Things that could signal certain diseases.
So instead of always needing blood tests or other, more invasive procedures, we could have these little sensors, like constantly monitoring our health.
Exactly. And they could be in wearable devices or maybe even implanted, kind of like little guardians keeping an eye on us 24/7. It's a whole new way of thinking about healthcare. And it doesn't stop at just diagnostics either. Imagine like using photoluminescence to activate a drug, but only in the cells that are actually sick. You could minimize those side effects and really make treatments more effective.
Whoa. It's almost like, I don't know, like you're using light to do surgery, but on like a super tiny scale. It's mind-blowing to think about how photoluminescence could change healthcare in such a big way. But with all these amazing benefits, are there any, I don't know, any downsides or like challenges with this technology?
That's a really good question. Like with any technology, photoluminescence does have some hurdles to overcome. Like one thing is just making the materials themselves more stable and brighter, especially for things like, LEDs and those high efficiency solar cells we were talking about. And then, especially for biomedical applications where they're going to be interactive with the human body, we really need to make sure that they're safe.
So it's all about pushing those scientific boundaries, but also being responsible and ethical at the same time. It's good that researchers are keeping these things in mind as they explore all the possibilities of photoluminescence.
Absolutely. We want to harness its power, but do it in a way that's safe and beneficial. But, speaking of possibilities, where do you think photoluminescence could have a big impact in the future?
Well, you mentioned those tiny sensors that could track our health, right? What if we could go even further and use photoluminescence to create like smart materials that can sense changes in their surroundings and then, actually react to them?
I love that. Imagine clothes that change color based on your body temperature or buildings that automatically adjust their lighting depending on how much sunlight there is.
Yeah, exactly. It's like we're talking about giving everyday objects a kind of intelligence, using this whole idea of light emission and absorption.
That's a great way to put it. I'm really starting to see that photoluminescence is way more than just a cool science thing. It's a gateway to a whole bunch of possibilities.
Totally. So what's the biggest takeaway for our listeners today? What's the one thing you want them to remember about photoluminescence?
I think the most important thing is to remember that you should never underestimate the power of things that seem simple. Photoluminescence might seem basic. At first, light goes in, light comes out, but it really has the potential to change the world. From creating cleaner energy to developing incredible medical technologies, the possibilities are just huge.
It's a good reminder that sometimes those really impactful solutions come from the most unexpected places.
Totally. It's all about being curious, open to new ideas, and realizing that even the simplest things can lead to some amazing discoveries.
So next time you see something glowing, whether it's a firefly on a summer night or even just your phone screen, remember that there's a whole world of science and possibilities behind it.
Beautifully said. Who knows, maybe one of our listeners will make the next big discovery in this awesome field.
Now that's a thought that really gets me excited. So we've talked about how cool photoluminescence is in LEDs and how it could change things like renewable energy and medicine. We even touched on those smart materials that can like react to their surroundings. What other cool stuff are scientists working on with photoluminescence?
One area that's super exciting is developing new materials, but like with even better photoluminescent properties. Scientists are, playing around with nanomaterials. They're like manipulating stuff at the atomic level to make structures that are way more efficient at absorbing and emitting light.
So they're basically making these tiny little antennas that are perfectly tuned to catch and release specific wavelengths. That's pretty wild. What could we do with these super efficient materials?
Oh, the possibilities are endless. Imagine LEDs that are like insanely bright but use even less energy. Or sensors that can pick up like the tiniest traces of pollutants. We could even have lasers that are way more precise and powerful, for things like telecommunications and manufacturing. It's pretty mind-blowing.
It really is. It's like they're taking this tiny little world of atoms and using it to create these huge changes in the world around us. It's a testament to how clever humans are and the power of science.
Totally. And this whole fascination with light, it's not new. Think about those early photographers. They were so captivated by the idea of capturing moments in time with light-sensitive materials. Or those inventors who created the first electric lights, like trying to banish darkness. Photoluminescence is just the next step in this journey of like mastering the magic of light.
That's a great way to think about it. It's this ongoing story of humans trying to understand, control, and use the power of light.
Exactly. And that story's still being written today. Scientists are always pushing the boundaries of what we can do with photoluminescence, like exploring new materials, techniques, and applications that could change our lives in ways we can't even imagine.
So, for all those science nerds out there, or anyone who just loves a good light show, what would you say is the most important thing to take away from all this?
I think it's important to never stop being curious, like pay attention to the world around you, ask questions, and keep learning. You never know what you might discover.
That's great advice, and I think that's a perfect note to end our deep dive into the fascinating world of photoluminescence on. It's been a really cool journey exploring the science, the possibilities, and just how much potential this phenomenon has to shape the future.
It's been awesome chatting with you and all our listeners about it.
Thanks for joining us on this journey. Until next time, keep those minds curious and those imaginations glowing.